From San Antonio, Texas, the home of VTDRB, this is an ODA presentation. Welcome to this session specially designed for certification engineers. I'm Julie Svoboda. Whether you are new to certification or have years of experience, the helpful information presented here will feature methods, processes, tools, and requirements for successful project completion. Different narrators will be participating. You will see their names at the bottom of the screens. So let's get started with certification engineering training.
Achieving an approval from the Federal Aviation Administration, or FAA, has always been a challenging process for companies trying to get their product to market. The process is heavily influenced by changing regulatory requirements, individual interpretation of those requirements, and shifting norms within the aviation industry. What we used to do in the past doesn't always work today or in the future. This moving target can make it difficult to be a certification engineer, as it's hard to be absolutely certain based on previous experience. I'd like to welcome you to the first module of the Certification Engineering Training video program. This training is intended to accomplish two things as we cover the certification process. First, provide a foundation for understanding the certification process, and then describing the processes that the ODA uses to ensure compliance through standardization and consistency. In an ODA environment, there are certain tasks and responsibilities that certification engineers take on beyond what is normal for a standard FAA managed project. We'll focus on those areas. In the ODA in-house training module for unit members, the one titled ODA Overview provides a good explanation of the differences between working on behalf of an applicant versus working on behalf of the ODA. If you haven't watched that module, I strongly suggest that you do, as the information complements what will be covered in these modules. These modules will look at the full scope of the approval process from the perspective of a certification engineer rather than a unit member. If you have any questions, feel free to discuss with Candace, Bob, or myself. The certification process is defined in FAA Order 8110.4. In short, it's based on the scientific method that we all learned in school to some degree or another. The process of the scientific method involves making conjectures or a hypothesis, like, I think my wing is XYZ strong, and then deriving some predictions from them as logical consequences, such as the wing will break when loaded to X amount. And then you carry out experiments or empirical observations based on those predictions. The purpose of an experiment is to determine whether the observations agree with or conflict with the predictions that were derived from a hypothesis. In certification, the regulations that we use provide that bar, or the minimum level that we need to meet to be able to show compliance. Sometimes these are really clearly identified, and other times they're just a little bit more philosophical. Now, there's a number of graphics available to represent the type certification process that is defined in Order 8110.4. I've always preferred this hill graphic as it's simpler than some of the others, with a little bit less jargon. This training module is going to walk through each of the items on the path, with more emphasis placed on the areas where we're most involved. You'll notice that this graphic starts with a familiarization meeting. From an FAA or an ODA perspective, that's where the process starts. But that's when the regulators first learn about a project. However, as a certification engineer, the process starts way before this point. All of the initial design, the vendor contracts, the project planning, and business relationships have been set up to some degree much earlier than step one. Questions about who's doing what, budgets, and the project scope have already been established. The certification process doesn't consider this side of a company's efforts, but a project doesn't exist without it. Since this module is focused on the certification process, we're not really covering what happens in getting an engineering design to the point that it's ready to go through the process, other than looking at where compliance planning starts. For information regarding that piece of the puzzle, ask the certification manager at your company. So where does compliance planning start? First and foremost, it's understanding the scope of the project. What does scope consist of? Now, Order 8110.4 doesn't really define project scope, but it does state When the certification plan does not give the FAA assurance to the applicant's understanding of the scope and magnitude of the certification project, the FAA should reject the application and consider the need for another familiarization briefing. Our planning efforts need to reflect that we understand the scope of the project fully. A lot of comments I provide on project-specific certification plans, or PSCPs, are related to poorly defined or understood scope. And this is actually an area where unit members also complain regularly. So it's an area where improvements can be made. You need to be able to define what the project entails. Now, there's lots of definitions for project scope online. As a PMP, though, I usually refer back to the PMBOK, or the Project Management Book of Knowledge, Standard Information. And it says that scope is the work that needs to be accomplished to deliver a product, service, or result with the specified features and functions. Before beginning the planning process, it's essential that a certification engineer understand the features and functions that are being delivered. Without that understanding, you'll be relying on everyone else to determine if the planning documents are accurate or not. Rather than approaching the process knowledgeably, work with the assigned project manager or engineer and make sure you've got a good definition of what's included in a project. In conjunction with understanding the project scope fully, planning for the certification effort is also occurring. Order 8110.4 defines the requirements of a certification plan for the type certification process. Order 8100.15 defines the requirements of a certification plan for all ODAs. And our ODA Procedures Manual further defines the elements we will include in our developed certification plans. We have to meet all of those requirements. The Procedures Manual encompasses what is already defined in the orders, so it's actually the one that takes precedence, as ODAs are required to follow the Procedures Manual. In the ODA Overview module, you'll remember that as a certification engineer, you're responsible for helping the applicant achieve approval for their product, not organizationally part of the ODA unit. The ODA unit should not approve a document that doesn't meet the Procedures Manual requirements. It's in the applicant's best interest to develop a certification plan that meets the requirements up front. To help streamline the process, templates have been developed to begin the planning process that include a PSCP, a compliance database, all elements of the project notification letter or P&L package, conformity planning spreadsheets, and an inspection database. Proper use of these tools is really important, so much so that we actually will cover them in a separate module. Establishing the certification basis is also extremely important to the project, as everything done after that point hinges on the decisions regarding where compliance must be shown. From Order 8110.4, it says, early in an STC project, the FAA establishes the certification basis, defining the applicable requirements. The issuance of the STC, the certification basis includes the specific 14 CFR parts and amendment levels. Each applicant must show compliance before the issuance of the STC. The certification basis includes the applicable airworthiness standards for the category that the STC is going to be issued. It also includes the applicable aircraft noise, fuel venting, and exhaust emission requirements. The certification basis is established by the FAA and agreed to by the applicant based on a mutual understanding of the design features of the product to be certificated. Upon agreement of the certification basis, new policy will not be imposed unless the policy is needed to address an unsafe design condition the FAA has corrected by mandating a change on other projects with the same design feature. Order 8100.15 defines how the FAA establishes the certification basis, further by explaining that the Project Notification Letter Response, or PNR, provides acknowledgement that the certification basis is acceptable, including any limitations, conditions, or objections. As we're not working on new type certificate programs with a brand new airplane, we're usually starting with a certification basis that was originally created for that airplane that we're modifying. The FAA specifically addresses this scenario in Regulation 21.101A, which states, an applicant for a change to a type certificate, which is what an STC is, must show that the change and the areas affected by the change comply with the airworthiness requirements applicable to the category of the product in effect on the date of the application for the change. However, we're working with airplanes that didn't meet the newest regulatory requirements. In fact, a lot of the aircraft that we work with are much older and couldn't meet the newer requirements even if we wanted to step up to the latest. Luckily, 21101B gives us an out, and it says, an applicant may show that the change in areas affected by the change comply with an earlier amendment of the regulation. However, the earlier amended regulation may not precede either the corresponding regulation included in the type certificate. Applicant may show compliance with an earlier amendment of a regulation for any of the following. 1. Change that the FAA finds not to be significant. Changes that meet one of the following criteria are automatically considered significant. 1. General configuration or the principles of construction are not retained. For example, we take out the entire electrical system and start from scratch with a new technology like wireless transmission. Or we decide to add composite wings to an aluminum fuselage. 2. The assumptions used for certification of the product are changed and do not remain valid. Maybe the original aircraft assumed a certain operation, like being a passenger airline, and was later turned into a fire bomber, significantly different flight parameters. That's a significant change to the assumptions that have been made. 2. Each area, system, component, equipment, or appliance that the FAA finds is not affected by the change. 3. Each area, system, component, equipment, or appliance that is affected by the change would not contribute materially to the level of safety of the product or would be impractical, imposing damage tolerance on an aircraft that was originally not analyzed in this manner.
Most of our projects are not significant, but on occasion we do have one that is deemed significant, usually because the original certification assumptions are no longer valid, like projects changing from analog gauges to digital. How do you know? Advisory Circular 21.101-1 provides a process for evaluating a change to see if we can use the exceptions when developing the proposed certification basis. In the PSCP template, there is a table developed to conduct this assessment. Each step in the AC is addressed, and if you're not sure what's being looked for, read the guidance provided by the FAA. If it's still not clear, look at other similar projects for how they were assessed. Do not just cut and paste, though, as this does need to be thought through and accurately assessed. As this is the starting point of a project compliance plan, failure to get the right answer can really cause significant problems. If a project is significant, we must begin the issue paper process to develop the appropriate certification basis. This is normally accomplished using a G1 or general issue paper format. The intent of a G1 is to spell out which regulations and amendment levels are appropriate for a specific modification. This is coordinated through several offices within the FAA, such as the ACO, Directorate, and AEG, to reach agreement that everything is fully covered. There are other times when issue papers are also used, and they're not only for significant projects. Issue papers can be used for anything that doesn't quite fit into the norms of certification. For example, sometimes it's impossible to show compliance with the regulation because it is too prescriptive for the situation, like when it says a gauge must operate in a specific manner, which is great for analog gauges, but impossible for digital ones. In those cases, the FAA can determine that something meets the intent of the regulation or provides an equivalent level of safety. There are also times when the method of compliance described in an advisory circular just doesn't fit a situation. Issue papers can be used for this too, to get FAA buy-in for how an applicant wants to go about showing compliance. For example, installing a shower isn't new or novel and is covered by the current regulations, but there isn't a lot of guidance available because this doesn't happen very often. A method of compliance issue paper can spell out the unique things the FAA wants considered prior to approval. All issue papers are coordinated with the FAA, so cannot be handled solely by the ODA.
Knowing a project is not significant, or even if it is, the next step is to understand the certification basis of the airplane or airplanes that we're working with. This starts with reviewing and understanding the most current Type Certification Data Sheet, or TCDS. These can be found for every aircraft certified by the FAA at the Regulatory and Guidance Library, or RGL.
Once you open RGL, you'll see that there are a lot of options listed. This is such a valuable website for certification work that you should save as a favorite and refer to it often, probably every day or even multiple times every day. You can find the TCDS link at the bottom of the list. From here, there's a number of ways to search. Whether you can type in the number, you only know the manufacturer's name, or even limited to something more ambiguous, like, I know it's a small helicopter. Once you determine which aircraft you're looking for, you can click a couple of times to pull up the TCDS. Reading a TCDS is not intuitive for anyone. It includes a lot of jargon. There are inconsistencies from one to another, and you can't always find the same information in the same place. Experience makes the review easier as you get used to reading through them. One thing to note from the very first page is that the approval must be against the make and manufacturer as it's listed on the TCDS. You may know an airplane by its marketed name like 737 Next Gen or Cessna Caravan, but that's not what's listed on the TCDS. So, 3 key pieces of information are the name listed as the type certificate holder, which is the aircraft make even if it used to be a different company. Also, note the models listed in the right-hand corner box. We use this nomenclature for the model, even when we may know it as something else. Finally, it's also important to note the revision of the TCDS. These are updated regularly and can affect projects. The certification basis shouldn't change, but names change, ADs are issued, all of which can make the project need to switch gears. From the first page, scroll to the section of the document that is specifically explaining the model we're working with. Read through the content. A lot of it isn't relevant to our project, but on occasion, information that is relevant is tucked into an area that's unexpected. Note the things that seem pertinent to the work we're trying to accomplish. This could include eligible serial numbers, maximum passenger counts, operating limitations, etc. Then find the section called Certification Basis, or looks like Certification Basis. This is where the FAA spells out the amendment level of the regulations used to certify the airplane. You'll see for the 737-900, they used Amendment 91 with some exceptions. These exceptions include special conditions, equivalent levels of safety, and exemptions that were granted. We need to understand which of these may be applicable to our project. For example, we had an interior project where the regulation states that survival equipment must be attached to life rafts, but the company had the equipment in a cupboard nearby. In reviewing the TCDS, we found an ELOS allowing for the equipment to not be attached. Even though we now know the certification basis amendment level for an airplane, it's not as simple as saying we met Amendment Level 91 for everything. When we look in RGL at the Code of Federal Regulations, you'll see that there's a history associated with every single rule. And as you scroll through the regulations, you can see that there's not a lot of 91s listed. This means that when the FAA amended a FAR part, like at 91, only a handful of rules were actually changed. So the other rules kept being applicable with wording that was published at a different time. So, for example, 25.321 was at Amendment 86 when Amendment 91 was published. Without checking the TCDS for the exceptions, we would know that if 25.321 was applicable to our project on a 737-900, we'd need to show compliance to Amendment Level 25-86, most likely. To confirm this, we'd go back to the TCDS and check the exceptions listed. 25.321 isn't listed, so yes, the appropriate amendment level would be 25-86. We do this for each regulation that is applicable to the project to create a compliance checklist using a project database, which we'll cover in the Tools module. You may be asking, how do you know which regulations are applicable? We've developed some standardization checklists that show which regulations are normally applicable for similar projects. There will be differences between projects because of unique elements, but these checklists serve as a starting point so that we can be consistent across like projects. These can be found in the ODA P drive folder or SharePoint. They're not intended to be used blindly, but should help provide the bare bones minimum of what should be included.
Keeping track of the certification basis and when compliance has been shown is the crux of a certification engineer's job. There are a lot of moving parts and it can get complicated. As an applicant, 14 CFR 21.21 says that one is entitled to an STC once they submit all the type design, test reports, and computations necessary to show that the product to be certificated meets the applicable requirements prescribed. That's why we put such effort into developing better processes, so it's more certain that everything is accounted for. This includes putting tools in place to help communicate the plan to all involved parties and to get their buy-in, to track when compliance is complete by regulation and to know when things are late or when an issue may need resolution. When developing the certification basis, the certification engineer is usually also building the compliance database that is used to identify the applicable regulations, what documents will be used as evidence for compliance, and which ODA unit members are anticipated to conduct a review and approval. There are questions that need to be answered when developing a plan. These are found in the STC checklist and also in the database, so that all of the correct initial steps are completed. There's also a project-specific certification plan or PSCP template available that helps guide a certification engineer to determine what information needs to be figured out. Of course, a certification engineer isn't the only person providing their expertise into planning. It's also necessary to work with company project managers, engineering, and the ODA to best ensure everything is fully addressed. This can also include vendors, modification facilities, aircraft owners, and FAA involvement in project oversight. This can get kind of confusing. Order 8100.15 recognizes that differing responsibilities need to be clear. It states, projects that involve numerous parties in the design or manufacture of articles require additional scrutiny on the part of both the ODA unit and the OMT. The OMT must evaluate the capability of an applicant to perform such projects, considering the experience and competence of the other parties involved during the review of the P&L. So we have to ensure that this is very clear in the PSCP. It's extremely important for everyone involved to know who's doing what.
The ODA Procedures Manual states, the lead or project ODA administrator will choose unit members for projects based on their qualifications and specialties, not on the preferences of VTDRB, applicant requests, outside influences, or level of financial burden the selection may place on VTDRB. In the past, certification engineers would make contact with ODA unit members and get their commitment to support a project prior to ever coordinating with the project ODA administrator, the POA. This has caused problems with resource loading within the ODA, poor development of a robust ODA unit, and misunderstanding of roles. To address these issues, a form has been created to propose unit members to the POA before a CERT engineer reaches out to see if the person can support a project. This early coordination is expected to smooth out some of the hiccups that have been experienced. Further to smoothing out responsibilities, a statement of work should be printed from the project compliance database for each unit member that is supporting a project so they are clear on what is expected of them from the ODA. This is in addition to any statement of work or contractual arrangements made by the applicant.
Once a PSCP is drafted and ready for coordination with the ODA, the draft document and some printouts from the project database should be provided to each unit member that's participating in the project. These printouts include the unit member document list and the applicable policy for a project to review reports. These reports provide differing perspectives for reviewing information captured in the PSCP to help know what might be missing or not captured properly. To gather signatures to show unit member concurrence, the PSCP will be sent to all involved unit members via DocuSign to gather electronic signatures. Each certification engineer should have an account to use to send documents for signature. It's extremely easy to use. The important thing to remember is saving the signature certificates as evidence that the sign-off is valid. Order 8110.4 defines type board meetings as any formal meeting between the TCB and the applicant to coordinate the move to the next project phase or resolve issues, preventing progress to the next phase. Examples include preliminary, interim, pre-flight, and final TCBMs, where a type certification board or the TCB, is the FAA management team responsible for acquainting the applicant with the certification process, resolving significant problems, and establishing a schedule. With ODA projects, these are usually between the ODA team and the applicant team, but the FAA can always participate as well. Where the order calls an initial formal meeting a preliminary TCBM or familiarization briefing, we usually refer to it as the familiarization meeting. This normally happens prior to sending out a PSCP for unit member reviews. The intent is to provide an applicant or the company the opportunity to provide an overview of the technical aspects of the project so that there's a broad understanding of what's coming. This is not the time to hand out the PSCP and read it at meeting participants. Let's not bore folks. Nor is it the time to assume that everybody already knows what the project's about. A certification engineer, along with any other engineer or suppliers needed, should be able to present information regarding the design, supplier support, unusual vendor relationships, how previously approved data or equipment is being integrated, what drives a project schedule, and how compliance is expected to be shown. Again, we're back to that project scope, being very clear on what's going to happen. The expectation is to get participants engaged in a discussion early so that questions can be answered up front in a program. One key tool available to certification engineers that hasn't been mentioned yet is the certification job aid in the ODA SharePoint. Lots of guidance is captured out there about differing topics regarding the certification process, including what's expected for TCBM meetings. You can find an explanation about what's expected at a meeting or a list of the items should be prepared to show during a presentation to answer questions. For example, the pre-TIA TCBM occurs as the project is winding up and getting ready to move into flight testing. Because of the risk associated with the flight test program, this TCBM is expected to provide a status of all the company development that's taken place, explain any changes that have occurred due to testing, and explore any risks associated with proceeding with testing so that mitigations can be put in place. From Order 8110.4, these meetings also identify any outstanding conformity inspection issues and engineering compliance determinations. During the planning phase, each compliance item is defined as required to be complete prior to TIA. Everything that can impact safety should be identified like that, or can be completed after, like a damage tolerance analysis. This is the time to see how things are shaping up. The final TCBM is required for projects that had flight testing and are again a time to provide status of the project, but more specifically, verify each technical discipline has accomplished everything needed to show compliance. There's another set of status documents required to show what's been completed. Even projects that did not include flight testing will have these status documents generated to show where things stand. There's just an option to have the certificationeer and project ODA administrator, or the POA, discuss them rather than having the whole TCB. It will depend on project complexity and the POA will decide if a final TCBM is needed or not. So in mentioning that part of the process is being able to status conformity inspections, it's pretty helpful to understand what conformity is. A much more detailed description is offered in the conformity module, so watch it. Watch it twice, in fact. Conformity is the most misunderstood aspect of the certification process from my perspective, so spend some time with the training to make sure that it makes sense to you. Order 8110.4 devotes an entire chapter to the conformity inspection process, so you can refer to Chapter 5 for more information. In a nutshell, the order explains the applicant must conduct all 100% of the inspections and tests necessary to determine whether the item, a part, assembly, or the airplane, conforms to the proposed type design data. The manufacturing inspector, or unit member in our case, verifies the applicant's conformity is accurate and complete, and the applicant complies with 14 CFR 21.33b. The manufacturing inspector also coordinates tests and evaluations when requested. The manufacturing inspector and the ACO, or ODA, engineer determines the product can be consistently produced according to the type design data. As an aside, you may be asking exactly what is type design data. There's a regulation that defines this as well. So 14 CFR 21.31 explains that type design consists of A, the drawings and specifications, and a listing of those drawings and specifications necessary to define the configuration and the design features of the product shown to comply with the requirements. B, information on design, materials, and processes necessary to define the structural strength of the product. And C, the airworthiness limitations section of the instructions for continued airworthiness. Type design does not include all the substantiation reports, test plans, or test reports that are developed as part of the project. Those are the means used by the applicant to show compliance, or the evidence that's used to make the argument that something complies. When we refer to a master drawing list, a design data list, or sometimes an installation data list, we're talking about the list that includes all of the type design data. It's usually the top-level definition of a modification that's listed on the face of the STC. You need to be able to trace through all design data from whatever that master list is. On the other hand, when we talk about a compliance data list, or a master data list, or master data package, we're talking about a list that includes more than just type design. These types of lists usually include all the substantiation documents, in addition to the design data in some fashion. Master lists, they are also updated when changes occur throughout a project and after approval is received when something is revised. Masters are used to control the configuration, so it must always reflect the current state of the applicable data. This one has been a confusing one, so we need to make sure we understand what the configuration is. Now that we've clarified what type design data is, let's move back to the conformity process. As a certification engineer, you know that the company must inspect 100% of everything regarding a modification. The ODA inspector doesn't. Since he's verifying what the company has inspected, it's a spot check more than doing an inspection twice, or conformity. The engineering unit member is responsible for determining what the ODA inspector looks at to do their verification. Only those with the 11070 authority, or the ability to establish conformity inspection requirements, get to do that. Many EUMs have this authority, but not all, so double check before you ask someone to sign off an RFC. Order 8110.4, the inspection unit member verifies the conformity of the critical and major characteristics of materials, parts, and assemblies. Help filter out the parts that are not critical or do not contain major characteristics. The ODA relies on the certification engineer to provide a list of items considered critical and have major characteristics as developed with the engineering team. EUM uses this information to establish where conformity inspections are required. Past programs, this information has been conveyed using a design data list, where the items to be conformed by the ODA were noted. However, the modification facility misunderstood and only inspected the items that were marked, not 100% as required. Communicating with the facility, who is responsible for conducting inspections on behalf of the applicant, it must be very clear that they are inspecting everything and they document it. If a facility or a vendor does not understand the conformity process, refer them to the conformity process video module. Testing can occur throughout a program, starting with component-level tests like seats or electrical equipment, to ground tests, and ultimately flight testing. To complete any test well, Order 8110.4 explains, the applicant must prepare a test plan when testing is necessary to show compliance to the regulations. The applicant should also submit the test plan early enough to allow the FAA, or ODA, time to review and approve the test plan before the start of the test. The test plan is used to ensure orderly and complete testing is accomplished. Just as we began this module discussing the scientific method, this is the time in the project where the hypotheses are being evaluated. To make sure the process is well defined, there are a number of items that must be included in a test plan. Certification engineers often write the test plans, so need to be familiar with all of the elements required. Some are included in the order, but there's also a standardization list provided in the certification job aid to help. After the test plan is approved by a unit member, an inspection unit member will need to conform the test article. Then, an engineering unit member will witness the test as it's performed. Often, the same EUM that approves the test plan will witness the test and approve the test results, but not always. There are cases when different individuals can do each of the 3 steps, but there is a process to help determine when this is acceptable. This is laid out in the ODA Procedures Manual, as well as the Certification Job Aid. There's also situations where a unit member may ask that a test setup is conformed, like test equipment, calibration, proper arrangement, etc., to verify everything is configured properly to gather the data properly. For example, conforming thermocouple locations is a common thing. Work with unit members to determine what conformity inspections are needed. When all of the required analysis and substantiation is complete, all the component and ground testing finished, the pre-TIA TCBM has convened, and the TIA has been issued, flight testing can begin. Order 8110.4 offers: for flight tests, the applicant performs the necessary tests and inspections and submits the results to the FAA for review. For certain flight tests, the FAA or the ODA may choose to conduct certification flight testing concurrently with the applicant. Due to the potential risk associated with flight testing, the FAA or ODA expects confirmation that the company was able to successfully complete higher risk tests before getting on the airplane. Since we can only do low risk testing concurrently with a company, it's important to not tell a company something different unless tests are indeed low risk. A risk assessment is used to determine which tests are low risk. There's an index in the ODA Procedures Manual that helps guide review of certain tests. These tools must validate that a test is low risk before the ODA will agree to concurrent testing. That's the purpose of the Safety Review Board meeting, which is most often held in conjunction with the pre-TIA TCBM. As described in Order 8110.4, risk assessment is normally done by a safety review process or project and non-project personnel review a flight test plan. This determines potential hazards and recommended mitigating or minimizing procedures. Both the flight test pilot and the POA agree on the risk assessments, which is shown when the pilot concurs and the POA signs the TIA. For medium and high-risk tests, the FAA must be coordinated with to see if they'd like to participate in the Safety Review Board and to get their concurrence on the risk level defined.
When everything is completed for a project compliance report is generated to explain the outcomes versus what was originally planned. In Order 8110.4, this is called a certification summary report, as is summarized as an executive summary containing a high-level description of major issues and their resolution. The report should be used as a means for retaining corporate knowledge and lessons learned that could be beneficial for future projects involving the same or similar type design. Another benefit of this summary report is in a non-concurrent validation project. It serves as a useful tool for a foreign CAA to learn what FAA concerns surfaced during the project. A template exists for this report and is created by exporting a lot of information from the project's compliance database and the conformity database. This report includes a signature block above the compliance checklist for the applicant to sign. The reason this signature must be complete before the ODA can make a final approval is 14 CFR 21.20, which states, the applicant for a type certificate, including an amended or supplemental type certificate, must A. show compliance with all applicable requirements and must provide the FAA the means by which such compliance has been shown, and B. Provide a statement certifying that the applicant has complied with the applicable requirements. The Project Compliance Report is accomplishing both of these objectives. When an STC is issued with a POA signing the certificate, the certification engineer's job isn't quite complete. There are a number of additional steps that need to be accomplished, which are listed on the STC checklist. One of these is collecting all of the project data into a folder and ensuring everything is retained within 30 days of issuance. This includes all conformity and airworthiness certification paperwork, which tends to be the hardest to retain. Work with the Records ODA administrator to make sure nothing is outstanding by the due date. Absolutely nothing.
Since we mentioned validation, let's talk about what that means. It's actually separate from the certification process described in Order 8110.4 and is covered instead by Order 8110.52. This order explains validation as the statute, regulation, and the clarifying preamble language that provide the FAA with discretion to issue a validated TC or STC based on a corresponding certificate issued by a foreign civil aviation authority when the FAA finds that it meets our airworthiness standards. This approach allows the FAA to address system differences above the project working level, thereby promoting an effective and efficient validation process while also ensuring an acceptable level of safety. This is the same principle used in the opposite direction, where certificates issued by the FAA can be validated by CAAs in other countries by showing that their standards have been met. Communication with other countries is normally between the FAA and the CAA office, where there are bilateral agreements in place that explain how the two countries will work together. The order also explains, in rare instances for outbound validation, U.S. applicants will directly contact a foreign authority to submit a validation application. While it is not typical, there is no regulatory requirement for an official agreement to be in place for the FAA to export our products. If an agreement, i.e. bilateral implementation procedures or equivalent, is in place, communication should always be conducted in accordance with the procedures prescribed. In the majority of instances, the lines of communication are limited to only the validating and certifying authorities. In lieu of an outbound agreement, however, the FAA Project Office will attempt to contact the cognizant foreign authority and establish communications prior to initiating any export processes. So as a certification engineer, there are a number of things to know about before beginning the validation process. The FAA keeps a listing of all bilateral agreements that are in place with other countries. These are easily searchable online. For example, let's look at what is provided for Australia. You can see there's a long list of agreements in place. You'll notice that they have a bilateral airworthiness agreement, or BAA, and a bilateral aviation safety agreement, or BASA. A BAA is an older version agreement and are being moved to the newer format contained in a BASA. These are mostly high-level agreements that are more state-level information and often do not include the details of what's expected from a process perspective. Usually, you'll find the details of interest in the implementation procedures for airworthiness, or IPA. Not all countries will have an IPA, but if it exists, it might be the best place to start a review to learn what will be expected. On the website, the FAA has also provided some helpful information in their link titled Obtaining Certification Approval from this country. In this case, you'll see that it's automatic. This isn't the case for all countries. But luckily, the process is simple with Australia. The European Aviation Safety Agency, or EASA, covers many countries, and there is a lot of information covering how the FAA works with them. In this case, they also have technical implementation procedures, or TIPs. TIPs contain the details when working with EASA. However, Order 8110.52 was based significantly on this relationship, so the process mimics what you will find. For some European Union countries, old IPAs may be handy in some situations. So take a look at them if we're working directly with the country rather than EASA. If a country does not have a standing agreement, as mentioned earlier, coordination through the FAA is still expected. So we must provide contact information and draft letters to help facilitate facilitate the communication that needs to occur. This starts with sending an application through the FAA to the country where we're validating a product. The country should then provide a list of what they'd like to see. In general, many countries accept FAA-approved data with little additional review. One of the principles offered in Order 8110.52 is the FAA's primary validation principle is to use a discretionary or risk-based approach on the applicable bilateral framework for determining whether an FCA's approved type design directly meets our airworthiness requirements or their equivalent. The validation of a FCA's approval is based on several factors, including our level of confidence in their certification safety system, their ability to make compliance findings in a consistent manner, their historical issuance of certificates that meet minimum safety standards, and their ability to support the FAA when conducting effective continued airworthiness. In general, other countries should work in a reciprocal manner.
After all of the work that goes into getting an STC approval, it would be nice to think that we're done, but things change. Customers ask for updates. We find issue in service, or the original configuration doesn't quite work for follow-on aircraft. All of these scenarios can drive changes after the original approval. 14 CFR Part 21.93 defines changes in type design are classified as minor and major. A minor change is one that has no appreciable effect on the weight, balance, structural strength, reliability, operational characteristics, or other characteristics affecting the airworthiness of the product. All other changes are major changes. In theory, this makes sense, but in practice, this can become a very muddled mess. So let's break it down a little bit. The rule says all changes to type design are major or minor. There's nothing in between. So we can establish a spectrum to see what kind of changes fall where. The rule goes further by saying a change that has no appreciable effect is minor, where appreciable can be considered something that can be measured. So if I were to test a configuration with the changes made, could I measure a difference? If so, it's a major change. If not, it's minor. So major changes involve adding a new aircraft to the STC through an amendment, creating a new configuration, or updating a design in a way that could have a measurable effect on previous test results. Minor changes, on the other hand, don't have an appreciable effect to type design. So, for example, when an airplane is repaired, the expectation is that you're returning the aircraft back to its original state from a strength standpoint, or the same electrical load, etc. Type design can be altered and still be considered a minor type design change, but it's called a major alteration. For example, aircraft have differences, so a wire routing or certain structural elements that looked one way on one airplane might need to be adapted to fit another airplane. The changes won't affect the test results. They're not appreciable, but it's a major alteration because it really isn't what was originally approved.
There are also changes to type design that aren't major alterations, but only minor. The FAA publishes a job aid for major repairs and alterations to help determine where things fit. It's updated regularly, so should be accessed from the FAA website to make sure you're working with the latest information. Start by selecting the type of aircraft under consideration, then the technical area. You can then read through the elements to see what type of classification the FAA thinks a change would fall into. STC is the easy one, as they're saying you need to get an STC for those kinds of changes. It's a major change. ENG and EVL are a little less clear. ENG means an engineer needs to evaluate to make the determination or approve the associated data. These are typically the items the ODA completes as a major alteration. Items marked as EVL rely on the FSDO inspector to determine if he will complete as a field approval. A field approval by a FSDO inspector and an MRA project are the same. But industry prefers field approvals or return to service with DER approval, as they feel they have more latitude. That is accomplished at the discretion of the repair station. If we have a change that does not exist on this list, it does not qualify to be an ODA project and can be handled in a simpler manner such as a logbook entry. Order 8300.16 can provide more guidance regarding which approval method is best for a given situation.
In wrapping up this module, recognize that we have only summarized the certification process in Order 8110.4. To be most effective at your job, you should be familiar with the order and the FAA expectations that are provided. Remember, however, that when working with the ODA, the procedures in their manual are the governing processes. You may find a place where the order spells out one thing and the ODA does it slightly different. For example, the FAA uses their NACIP system to issue requests for conformity, but the ODA uses a different database. The ODA procedures must be followed, but understanding where they come from in Order 8110.4 will make you more knowledgeable about why and what the overall objectives include. If you have any questions regarding any material in the module, please contact the certification manager of your company. If your questions concern the ODA, feel free to ask the ODA administrator as well.